Testing. Bernard, can you hear me?
I can hear you.
Awesome, thanks.
I figured we'd wait till Eric gets here.
Yeah, and yeah, until 5 past, general. All right, I think people are filing in virtually. I think maybe we'll start at 5 past.
We can probably start the nagging a bit early. Do we have a volunteer for note taker?
All right, folks, we need a note taker for the meeting to start. You know the drill. And with these virtual calls, I can't just awkwardly stare at people.
But you can talk about doing it.
Well, let's see. I can turn my camera on and stare into the webcam, but I don't. It's less fun if I can. Normally, everyone looks down at their laptop for some really important email at that moment. Folks, we don't need the minutes to be too precise. Remember, these days we have the YouTube recording just to kind of. I mean, if you're willing to do the first half, Martin, that would be super helpful. And is someone willing to do the second half?
And the nice thing is with the note taking tool, right? Anyone can do it. Easy.
Apart from the fact that the note-taking tool, if you're not logged in, doesn't open the note-taking tool.
That's right.
Thank you, Lucas. All right, thank you, Lucas and Martin. And all right, let me see if I. All right. Cool. And just to make sure we're all there, here's the link in the chat. All right. Bernard, you want to kick us off?
Sure. This is the WebTrans working group. We have 2 hours together. Hopefully we won't need every little bit of that. But a few reminders, this session is being recorded. I think by now everyone knows how to use Meet Echo, but please use the Q hand tool to get in and out of the queue. And don't forget to unmute yourself or we're not going to hear you. Note well. So IETF policies in effect on topics of IPR, etc. And it's detailed here. By participating in the IETF, you agree to follow the processes and policies. Definitive information is at the drafts below. Please read them and understand them. And then we have standards of professional conduct in the IETF, guidelines of conduct, anti-harassment policy, and procedures. If you have any concerns, please talk to the ombudsman. All right, a little bit about the meeting. We do have a note taker, thankfully. I guess, David, you'll be the Zulips scribe. And we have notes for people to take notes in. So here's the agenda. We're going to have Jan Ivar do a W3C update, and then we're going to get into the core of the meeting, which is really about MAC streams and flow control. And we have a number of drafts, which will represent potential solutions to this and lots of slides to go over on it. So that's the focus of what we're going to be doing today. And then at the end, we'll try to wrap up and summarize what we've figured out. Okay, Jan Ivar.
Hi, can you hear me okay?
Yes.
Yep.
All right, great. Hi, I'm Jan Ivar from Mozilla. I co-chair the W3C part of WebTransport with Will, who couldn't be here today, so I'm doing the update. So this slide is pretty simple. We will present a full update in Brisbane for IETF 119. But for this interim, we would like to focus on two issues, one PR and one issue, which we have IETF dependencies on. And this is the first one, which is issue 411 over in our neck of the woods, which is to expose a TLS keying material exporter, unique value for the TLS session. This might sound familiar because I think it was bounced back. There was some, we reached out for more user support and there was a bit of a delay and people come back and I think it's libbed P2P, a specific user who wanted to, who had interest in this feature. So we're bouncing it back. And in short, it would be useful to expose a TLS key exporter from RFC 5707, or at least a value that's derived from the TLS master secret and therefore unique to the TLS session. We'd like to extend our use of WebTransport to use the web PKI extensions. Here, being able to derive a unique value would allow us to bind the TLS session to the noise handshake, similar to how we use server certificates. I don't know what a noise handshake is, but it sounds really cool. So, but this is apparently a useful building block for protocols running on top of TLS, and there's some strong support from the authors of this. So Victor reopened this in IETF, which is issue 116. So discuss. Any questions around this or concerns?
No concerns, but I know we've created TLS 1.3 exporters in other working groups. I'm just wondering if we're clear exactly what the function is. I think we are in other working groups, like EMU created one, but that might be something to check. Victor?
Oh, to answer that question, I think the exact function of this would depend on the applications it's building on top of WebTransport.
Oh, you mean the label would, right? But the
the label and the specific use, but it's up to the protocols that runs on top of WebTransport.
We're not asking to design the API in this working group, but I understand there are some parts that would be needed to facilitate an API.
Yeah, I'd say I think Victor had a PR written up for this, so I'd encourage if people have thoughts to go comment on the PR. Given that we have this request on the W3C, I think we'll look at it more seriously.
I don't believe there is a PR, but there is a proposed design on the issue.
Okay, so on the issue, so please comment on the issue, folks. And then ideally we can, like, so in a few weeks, we'll all be in Brisbane. So Victor, if you can have a PR by then we can discuss it in the room then and see if we can get approval, like if we can reach consensus on a design.
All right, thanks. And the second issue is issue 580, which tried to remove a dependency on data received. And we were able to partially remove it, but this line was proving a little difficult. It's a line that waits for the data to the internal stream to the send stream, sorry, to enter the data received state. And this was discussed in IETF issue 103, that it's actually useful for aborting a stream to create what we call partial reliable sending, basically to abandon data that's already been sent. And we would lose that feature unless we keep a signal in HTTP 3, and maybe not in HTTP 2, where we could add it, but it wouldn't be useful probably. So a similar PR was, so the other references to data received other than this one was removed. And again, Victor was supposed to, it says Victor to open an issue on the IETF side to update overview about the definition of streams to include some sort of omitted state. Victor, do you want to comment more on this one? Does that cover it?
Yeah, it turns out that due to API issues, we have to tell the upper layers when the stream transitions from the state where you sent Fin, but you can still reset it, and that would result in discarding data to the state when you can't reset it anymore because the old data is being acknowledged and there's nothing to do. That's the background for this issue.
All right, thank you. I see Eric in the queue.
Just a clarification question. So the proposal here is to keep the data received state, or is it to add a new state that better represents what we're actually trying to do?
Kind of both. The proposal is to rename the state from data received to basically all data committed. I think that was the name I was going to. And for H3, it would mean data received. And for H2, it means as soon as you write a fin onto TCP, you're...
Thank you.
Any other thoughts, comments? Martin?
So, Victor, I think the primary concern here was that there's that there's a distinction between the data has gone into the network and the data has geez, I'm struggling with this one a little bit because I'm trying to keep up with the notes. The concern is that there's a difference between H2 and H3 in this regard. In H2, once you've sent the information and the promises have resolved, it's gone. It's in the buffers and it's more or less committed, and there's nothing you can do about it. In H3, you can send packets and they might get lost, and you might have to retransmit them, and there's that window of time during which you might want to abort the retransmissions. And that's the window that we're hoping to exploit with this sort of partial reliability capability.
Yes, so one thing to note is H2 also has that window, so it's smaller. It's like you write a bunch of data and then you hit flow control, which is entirely plausible because the API lets you write like 10 megabytes at once. So you can still reset that and it will not write it to TCP connection. So
Right,
it is not entirely like meaningless in HTTP2 as well.
Yeah, I would have imagined that the promise resolution on writes, even though people tend to ignore those sorts of things, would happen once the data has been committed to the network. In the sense
Yes,
that
I
it's gotten
think
into the buffers.
this is specifically promise resolution on the close and not on write.
Okay. I think we need a little bit more clarity about what the distinction would be on each one of these ones to be confident this is okay. I don't want a situation where we are driving this based on acknowledgements or something like that, because we made an explicit decision not to do that. I think it has to be framed in terms of what has happened locally on the stack. So, all right.
Yeah.
More work required on this one.
Yeah.
All right, so more work needed. Is that and there's an issue to track that. Wait, that's issue 103. Oh no, that was closed. Victor, did you open an issue for this one?
Not yet.
Okay, but you'll open an issue and discussion will happen there. All right, thank you everyone. I need to drop at this point, so thank you everyone for your time.
Thank you for the presentation, Yanivar. All right, I think, Victor, are you, you're doing the intro here, right?
I think I'm reading up to proposal D and then starting with proposal D. It's Eric. Eric, is it correct?
Yep, that is correct.
Okay.
Awesome. Thanks, gents.
Okay. I assume I don't get slide controls or anything fancy like that. So I'm today. The main purpose of this meeting is to talk about the flow control issues that we had discussed it like for over a year now. And the flow control here is a very interesting issue because it is not necessarily what you would think when you say flow control. It's a bit different, and the difficulty here comes not from the usual flow control, but from the fact that we have a quick connection that it has for flow control, and we're trying to put flow control on lower layers of things that we're nesting in it. Next slide. So flow control in most general is a mechanism by which receiver can tell the sender how much it can send so that receiver can control the size of its buffer. This is mostly due to the fact that in Quick, once you acknowledge data, you basically commit to having it buffered. So Quick has a model in which basically you cannot send any data unless the receiver permits you to send that data first in the exact amount that the receiver specifies. So one observation here to start is that WebTransport is inside the Quick connection. So WebTransport is subject to all of the Quick flow control mechanisms. So to that extent, you cannot actually buffer infinite data. So that is not the specific issue what we're dealing here. So what do we mean when we say web transfer flow control? And next slide. The problem we're having is that the web transport sessions are kind of like virtual quick connections inside one big quick connection. And that big quick connection has some set of resources like bytes data on streams and numbers of individual streams opened. And there is a global limit that is shared by all of those virtual connections, but we don't really have a way to but there is nothing inherently preventing one connection just from using up all of those resources, which would mean that the other streams on that connection, other web transport sessions on that connection cannot send data, and neither can like HTTP traffic that is not part of WebTransport. And this applies, so I would usually talk about this like as a browser and browser's client to server, but this also applies on the server to client direction, because if you have some application backend running on server, it doesn't necessarily know what it's sharing the resources with in terms of other application backends. Next slide. So that is the problem, and there is some argument as to why this might not be necessarily the problem. So first of all, the observation is that at least in browsers, we generally don't share connections, don't pool unless you're already connected to the same website, and that is mostly originally was done for privacy reasons, but that also means that you cannot effectively DOS one of the websites that you share connection with unless you're on the same domain. So from that perspective, it is not necessarily a security issue. However, the counterpoint is that it is still a robustness issue. Imagine you have a web application and like it's a chat client, and you open 3 tabs for different chats, and all of them will open WebTransport, or even not chats, let's say video live streams or media streams. They don't necessarily know about each other. They might share the traffic. And typically, web applications do not actively synchronize state between tabs unless they go out of their way to do that. And this would lead, like, if we let one tab accidentally run out of flow control resources on its web transport connections, then others suddenly will start mysteriously working. Others will mysteriously stop working. And now this is actually really painful to debug, because you're viewing live stream on one tab, and on that tab it's using up all resources, but the tab that doesn't work, nothing happens there, and you don't necessarily even know it exists unless you're looking from the server perspective. And the second counterpoint is, even when you're connected to the same website, the same domain can operate multiple products that are offered by multiple teams that do not necessarily operationally interact outside of sharing the same load balancing infrastructure. Next slide. And another observation is that another reason we do it is that we provide flow control in H2, and it's flow control effectively per session. So when we bridge H2 to H3, we end up in a weird situation where one of those is flow controlled, another is not flow controlled, and now the proxy has to deal with this somehow. Next slide. So we have 4 proposals. They're named A, B, C, and D. The first proposal, next slide, is proposal A. And proposal A is we go through the counterpoints that were just brought, decide that we, for some reason, may choose to not care about any of them, ignore them, and just decide that we're fine with leaving WebTransport over H3 as is with no flow control mechanism. So the second proposal, next slide. Second proposal is proposal B, also known as the hints proposal. It does not have a draft dedicated to itself, but I outlined it before on the GitHub issue for Mac Streams. Next slide. So the idea of the proposal B is that we solve the problem where one WebTransport session can exhaust resources by making the sender somehow enforce the limits. And this is not that far-fetched. We kind of do that in browsers already when we do pooling, that we can throttle requests from one origin and do things like that. So the general idea here is, well, let's assume, so the problem here is in order for the sender, let's say the browser, to enforce resource limit on every session, it needs to know how much resources it has in total, and it needs to know how much resources each session could get. And the problem is that the way Quick is designed is right now it doesn't really give you that information. The way it works is it says something like max streams equals 100, and that means it can tell you can open streams, the 100 streams, but that doesn't mean that if you open 100 streams and then close them back, it's not guaranteed that you'll get extra 100 streams. Some implementations will do that, but there is nothing in protocols that guarantees that, and some of them might in fact decide to scale down your flow control window based on some factors or scale it up. So the solution here is we're going to give the sender some information from the receiver that will let it figure out how many exactly streams per session are allowed to be opened. And the reason that I'm referring to those as hints is that they're not really like strict limits. You can choose to not enforce them, but it is in your interest as a browser to enforce it, because otherwise your application performance will suffer. Next slide. So the overall idea as a model I'm operating here is that there is some total max number of streams, and some of those streams are HTTP streams, and the rest of those streams are WebTransport streams. And we are going to assume that every session gets some fixed number of streams. And by the way, I'm saying max streams, but you can replace this with stream data limit. It's the same approach. And so there's roughly this formula with 4 variables. Max sessions is a variable that's known to both parties already since we send it in the protocol. It's something that the server decides and tells to the client. And now the client wants to determine max streams per session and max HTTP streams. So there are 2 ways it can do it. Next slide. One is the sender tells it that, by the way, I will allow you to open up to 128 streams at once, and you're only allowed to open up to 10 sessions, and then the user agent can decide how it's going to allocate those between HTTP streams and WebTransport streams, and based on that, it can decide, okay, there are 10 sessions, they get 10 streams, and then 28 streams are reserved for your requests. And the alternative approach, which is actually even more simpler because everything is decided completely on the server, is basically you send max streams per WebTransport and max HTTP streams as a cadence explicitly, so you get to decide all limits on the receiver side. That's basically, both of those can be sent as HTTP settings. And next slide. The general advantage is that really conceptually simple. There are one or two settings that you need to send. It's really easy to implement. You just count your number of streams before opening, and if it sets a limit, you do not allow. Of course, there are two big disadvantages, and I feel like a lot of our discussion today is going to be around whether those disadvantages matter and how much we care about them, and whether there are more disadvantages that I've not thought of. Number one is this model only works if all of your WebTransport session get a fixed number of streams or stream data, and they're equally allocated. And that is kind of, in one case, there are cases in which you might want to do that heterogeneously, or there are cases in which you would be able to, like if you're talking H2 to the backend and you know already what your limits are, you can just propagate those limits directly to the peer. And this is not something you really get to do here. So if you have any limit mismatch between the ends of the proxy, you'd have to buffer. The second limit is basically, since this is a mechanism that is advisory, it means if the sender decides to not, I already mentioned that the sender, it is in sender interest to implement those limitations. If it decides not to, that means that every receiver, by which I mean every potential application at the end of the receiver, has to handle up to max session times the number of resources that it has, that it would normally expect to handle. So that is roughly the outline of Proposal B. Now, next slide is Proposal C, that has also been in various forms brought up, is that we somehow move this problem from WebTransport layer to quick layer. Next slide. And there are various similarly shaped proposals that I've seen. I'm aware of the list two with internet drafts and one with that is not to draft, but kind of conceptually implemented as an API. The idea is that, well, what if we make quick layer aware that there are stream groups or namespaces or what you call them, and they have some internal limitations, and that way QuickStack can do flow control for them, and QuickStack already does flow control, so it can do flow control for them too. And this gives you properties that are very similar to proposal. It says slightly Proposal B, but we're a number, so it's actually Proposal D that Eric is going to discuss, except it's entirely implemented on transport layer. Next slide. There are some advantages and disadvantages of this approach. Advantage one is I feel like there are many uses of this, and whatever work we would do in area of multiplexing quick connection to virtual quick connection would be applicable to other applications potentially, which is good. And that we won't have to do any flow control logic on WebTransport layer because it would be quick layer's problem, and quick layer already deals with flow control. And there, of course, the obvious disadvantage is that this would block on a quick working group because this is not in scope of WebTransport working group. And there is a lot of things to bike shed there. As I mentioned, there are at least two drafts there, and the drafts have very different opinions on how to encode things. And as I said, it is unclear how useful, while it is potentially useful outside of WebTransport, it's not necessarily actually useful outside of WebTransport. So it's unclear how much of that work would be useful. Next slide is option D, and this is Eric. You're muted.
How about now? Sweet. All right.
Can hear you.
Gonna click a few more things. How about the next slide? All right. Let's go to the next slide. And one more. Interestingly, both of those slides are marked as skipped in my copy of the presentation. So the general idea here, so we've just talked about kind of what would it take to add a hinty kind of thing. We've talked about what would it take to change quick to make flow control happen there. The other option that we have is to bring flow control to WebTransport directly. The general idea here is what we did in H2 is we said, hey, we've got these different layers. We'll look at a diagram for that in a second. But we don't really want to bring forwards the way that H2 does flow control. We rethought that a bit when we built Quick. And we're looking for something that is specifically separated out to look like Quick. Could we use that in H3 as well? So we brought a bunch of the Quick frames that were necessary for flow control in as capsules for H2. Next slide, please. What if we just used those same capsules everywhere? So we've already got the logic that knows how to talk about that. We've got all the text that knows how to talk about that. It looks very familiar to anybody who's used Quick because it's the same thing. We do it over H2. There's no reason we couldn't do it over H3, and that would layer nicely. Next slide, please. So this is a diagram that we've seen quite a few IETFs ago. It's not necessarily a perfect diagram, but it's kind of trying to make the point that on H2, you have a WebTransport session that is on a given connect stream, and everything happens within that single H2 stream. And so you have this top-level flow control for the stream that becomes essentially the global how many bytes can go through for WebTransport. But then you also want to be able to say how much data of actual application data can go, and I don't want to block that top-level allowance for my control frames. I still need to be able to get my control frames through and be able to do that. And similarly, datagrams are kind of accounted differently because we don't really flow control them the same way. We flow control them by throwing them on the floor if we don't like them. Next slide, please. And of course, we know that this is different for H3 because the WebTransport session is outside of that connect stream. It's kind of this top-level construct within H3. And so we have these native H3 streams. And that's kind of nice because we actually already have flow control for every WebTransport stream. So we don't even need to bring over all of the stuff that we had in H2. We really only need to bring over the things that are missing. So if we go to the next slide, we had defined an entire set of capsules for WebTransport. And some of these are H2, some of these are H3. This is a long list. It's not super fun trying to read through this all and make sense of it. So if we go to the next slide, I categorized a bit. And then there's this giant question mark in the middle of this, and we'll talk about that in a second. But fundamentally, H3 has during WebTransport session. Perhaps we should bring that to H2 as well if needed. Both of them use datagram, and H2 is about to start using closed WebTransport session. H3 already does. And then we have the equivalent of stream frames as WT stream. We have padding, which we don't need because that's natively already in H3. And then we have reset stream and stop sending, which of course you can just do on an H3 stream, so you're in good shape. Those are all kind of the main ones that you need to have streams working. And then there's flow control, which is basically max streams, stream data, and max data, right? You have the number of streams you can have. For each stream, you have a certain amount of data on it, and then you have the certain amount of data that you can use globally. And then there's blocked variants of that to aid in debugging, just like we have in Quick and H3 and everything else. However, I put a giant question mark on here because this isn't really the whole story. So if we go to the next slide, I've now added colors and dashes and rearranged things. But fundamentally, what I used the green dashed box to mean is in H2, WT stream is a capsule. In H3, that ends up just being the native H3 stream sending data on that stream directly. Same thing for reset stream, right? If you're in WebTransport over H3, when you want to go reset a stream, you just send a reset stream frame. You don't need a WT reset stream capsule. And so datagram and closed web transport session are the two that actually show up as datagrams. We send HTTP datagrams for both H3 and H2. So those are actually truly defined for both. But there's an equivalent concept for all of these that are in the green box as well. The notable one here is WT max stream data. That's what we were just talking about. We have H3 streams. They already have their own flow control. We don't need a new way to do that. We've actually already brought all of that logic in, and all of that already applies to H3. We're in good shape there. So what that means is that there's really only 4 things left, and that's conceptually 2 of them plus blocked variants for each in H2 that we don't have in H3. And that is, in fact, the flow control capsules. And so if we wanted to, what we could do is simply move those over. So if we go to the next slide, we could just take those and say, hey, you've got a max stream limit that allows you to limit the number of streams that each individual web transport session can consume. So now I can have one session that doesn't impact other sessions or other HTTP traffic on that H3 connection. And similarly, I've got max data, which says within that session, can I have a limit that's lower? And we tend to use that to lower the memory requirements for a given session while still allowing any individual stream to use more than a very small amount. So if I'm going to allow you to have 100 streams and I wanted to give you a megabyte per stream, that might be fine, but I don't really want to give you 100 megabytes. And so I might have max data be some lower value that is how much memory I'm actually willing to use. And I'm basically saying you can use almost all of that for any individual stream if you should so need it. So that's kind of the main thrust of the entire proposal, is take those 2 plus blocked variant remaining things that don't have a equivalent in H3 where we need to be able to say, please don't overwhelm me with this, that, or the other, and bring them to both. The other place that this came up is when we were having some of the conversations around when do you look at settings and how much does a server need to buffer before you're allowed to send things, and can we handle incoming requests before we know what session they're for, and things like that. And one of the things that came out of that was that having some form of flow control makes the story there much, much simpler. So ideally, we can take these, make them look the same across all the different versions of WebTransport. We can even reuse the same capsules. And that's essentially what the document here proposes. So next slide, please. It's really just those 4 capsules. This is them with fewer lines around them, but it's really the same thing. Next slide, please. We wrote all this down in the thing that you can go click in the PDF that we'll eventually have for this in case it's useful. And if we go to the next slide, that is happily our last option. So we very much have a do nothing, which I think we've been making a pretty strong case that we don't want to just do nothing. But we essentially have different layers in which we could add the flow control that we need, and having explicit flow control rather than a hint is not a particularly huge lift over having that hint. So that brings me to the end of this part. I don't know, David, did you want to take us through the rest? Specifically the timeliness part.
Sorry, I stepped into the other room at exactly the wrong time. I think, let's see, what is our next slide? Go to the next one, Bernard.
Slide 41.
Yeah. Oh, weird. I thought I had put all the options on that slide. Weird. Oh, I guess we didn't update the PDF version. Anyway, this is good. So pretty much what we're looking for is, like, the ideal outcome of this meeting is we walk away with one of these options that we like, and then kind of go from there. What are people's thoughts? I'm Just go ahead, Bernard. I think you're first.
Yeah, I guess I'd like Victor and Eric to just talk about the differences between the two. I mean, I think Victor made it clear that the hints one is simple because it's only on the sender side. But I'm wondering if Eric would talk about like what additional work would be needed and maybe what the advantages he thinks there are over Victor's hints.
Sure. So, I mean, fundamentally, hints as a, hey, this is kind of what I'd like you to do, and it might work and it might not be there, I think is deterministically less fun than saying, this is how much I'm willing to support for you. That's also a bidirectional thing. So if you're sending me data as a client, I need to be able to limit how much you can use. And I'd like to be able to do that in the case that I described where the max data capsule is used to be less than anything for the sum of the streams. So if I'm relying on just the fact that we have stream flow control in H3, that isn't actually sufficient at a session level. And I don't know that the hints covers that particularly well. Happy to be wrong there, but yeah, I think the main thrust of it is that the hints and the signaling necessary for it are not massively simpler than just doing the real thing with the extra 2 capsules. And so the value of having it be the same across different WebTransport versions and having it actually be a concrete, this is how much you can send in both directions are, in my mind, the biggest advantages, but there may also be others.
Thanks, Lucas.
Hello. Sorry. Maybe I missed it on this slide 40, but I'm not sure if the ordering is the timeliness that we think that what we pick is going to deliver or something. But I don't think that matters for my comment. Deferring and like saying we'll add it later doesn't seem very good to me, because like people want to ship stuff now and they might deploy some apps and then they don't want to have to come back and worry about this stuff. Hints just seem like a load of problems of like, yeah, we'll have a standard, interoperable something or other that doesn't really work except for kind of manual, like, oh, it works when you speak to my server or the server I developed, and then I want to bring in a third party intermediation or whatever, and suddenly things stop working very well. So I think, I haven't spent much time considering, but having something a lot more strict and mandatory feels better, even if that's going to take longer to do. And that my question would be then, of the options, like the final 2, C and D, put it in quick or put it in WebTransport, which of those 2 would be more timely? I don't know. And I don't know if we need to know right now.
Yeah. And speaking as chair of WebTransport, and since you're the chair of Quick, my gut feeling is that things will probably be more timely in WebTransport, because the applicability would be just to WebTransport. We could add it to the existing drafts process-wise. We'd have nothing to do. Whereas if we did it in Quick, we're talking, a brand new adoption call plus reasonable discussions about, wait, this is applicable to other things. Have we considered X, Y, and Z, which kind of opens up the design space. So expediency is not our only goal, but it is one of our goals. And I think doing it in WebTransport will get there faster.
Yeah, that would be my kind of inclination. Again, like I said, I haven't considered it as much as others, but doing it here seems better. And maybe, in some far distant future, we decide, okay, this is something that we could kind of subsume back into the transport layer, maybe, and kind of come back to the drawing board in a few years' time and make WebTransport v2 or something.
Awesome. Thanks. Martin.
Yeah, I think Lucas pretty much said what I was going to say. I think of the 4 timeliness approaches. I think we need something mandatory. Lucas's arguments about, oh, I introduce a new type of intermediary and it doesn't happen to implement something suggests that this sort of maybe only sometimes doesn't really work out very well. So I'm all for the first approach here, and I think given the previous discussion, I've been advocating for doing the work here rather than taking a dependency on something more general and quick.
Thank you. Victor?
Oh, 4 approaches listed on the slide, I'm more inclined to pick either 1 or 2. And depending on whether we pick 1 or 2, I will have different feelings about the 4 proposals that are discussed. So I'm not sure, like, those are completely decoupled.
Okay, that's a good point. Let's have Eric and Bernard speak, and then we'll ask questions specifically about this. Thanks, Victor.
Yeah, I think Martin brought up a good point there as well. The other thing that I think really, I definitely think doing it here is a fine thing to do. If in the future there existed a better session or group of streams concept within Quick, it would not be super hard to rev WebTransport to do fewer things. There is some niceness to having it be reusing an existing mechanism that we use for H2, because I don't know that we're necessarily planning on putting a lot of energy into making groups of things in H2, and it doesn't really apply there anyway. So from that perspective, having it shim that into what we have for H3, and then if we want to go and make something happen in Quick, we can always go and make something happen in Quick, and rev to pull it in the next version of WebTransport. We've already talked a lot about how we do version negotiation. Exercising that version negotiation would be totally fine. But I do think having it be mandatory, especially for intermediaries that are trying to forward potentially even between versions, saying, hey, I've got this mandatory pipe upstream where I have specific flow control requirements, and then on the other side, it's kind of going to be loosey-goosey, please try to not screw it up, makes it really hard for those people to do any kind of sane forwarding that doesn't involve them just doing a ton of buffering.
Thanks, Eric. Bernard?
Yeah, so I agree that I think it makes the most sense to do this in WebTransport. My personal preference would be of these timeless approaches, number 2, which is make it mandatory for pooling. I don't know if that addresses all of Eric's scenarios or concerns, but pooling has been slow to roll out anyway, so you might as well define it now rather than wait and then have the pooling implementations do that when they can become available.
Thanks. So let's, and I see you, Martin. I'd say let's focus on the question here. The sense I'm getting from the room is I'm not hearing anyone jumping up and down to support 3 or 4. And it's unclear 1 and 2. So if everyone could come in and like opine on whether they prefer 1 or 2, that would be helpful. Martin, go ahead.
That was exactly what I was going to do. I don't think this works if we only make it mandatory for pooling. If you think about the potential for a connection to be used for HTTP and WebTransport concurrently, having some limits on the WebTransport components is still probably necessary, even in that case. So you only have 1 session on the connection, but you have other HTTP requests being made. Now, maybe people have in their minds that pooling is, I want this connection exclusively for use of WebTransport, but that's not at all the view that I had. And if you have that possibility and you have a front end that's sending some requests one way and some requests toward a WebTransport session, then you end up in a situation where one can starve the other, and having some sort of session level flow control would be useful there.
Thanks, Martin. Eric?
Yeah, and in terms of 1 versus 2, I kind of end up in the same place of doing it just for pooling ends up being almost more painful. I think there's enough places where the am I doing pooling, do I have a weird bug, do I have a different implementation, I think being consistent there is helpful. I'm trying to think of other places where there's a capability that we'd be missing, so we can walk through that exercise. But I think having it just be mandatory and saying, hey, like, here's these two frames, you need to be able to figure that one out, is not a huge lift.
Thanks, Eric. Victor?
I'm more in support of 2 than 1. From general perspective, it's easier for implementers, especially those who don't need pooling. And we really don't want to make them do extra work because we already make to do them a lot of work that is somewhat vaguely unnecessary, and I don't think pooling really helps in case when you only have one thing on connection, and that's your web transport. Now, that is from theoretical point of view. From practical point of view, I don't think number 1 would work because Draft 02 is already exists and it's already deployed for non-pooled cases, and it does not require pooling. So if we're gonna try to get people to upgrade to something that is dramatically more complex for no value, I don't think they will just do it. We will be stuck with Draft 02 for a long time.
Victor, just to clarify your last point, are you saying that browsers wouldn't update to a new draft if it was
the
too much work?
browsers would update, but the server vendors is like... The problem is not with Draft 2 versus a future version with mandatory pooling. The problem is we already support a version that is easier to implement. So if people are faced with supporting the versions that is easy to implement and supporting a version that is not easy to implement, they will gravitate for one that is easy to implement.
Yes, though browser have the ability to deprecate Draft 02 at some point, right?
Subject to web compatibility constraints.
Okay, thank you. Alan?
I guess I wanted to ask a question clarifying, because we're throwing pooling around, but then Martin raises this point, and do we have the right definition? Does pooling, are we only talking about having more than one web transport session on a connection, or does pooling refer to having regular HTTP requests and web transport sessions? And like, do we have a good understanding of what that means? Because I think maybe my answer, if it was only ever web transport on a session, then I kind of would feel more like 2 is in the realm of possibility. But if we think that like you can always send like GET requests and stuff on the same connection as web transport, then like it seems like we have a problem that we have to solve. So I'm just not remembering if we have this written down somewhere, what it means and what the requirements are.
So my understanding, and please jump in to correct me if anyone disagrees, is that by pooling we mean anytime the web transport session has something else on the connection. So, and that could mean GET, it could be a second web transport. So like the non-pooling just means you have a one-to-one mapping from your web transport session to your quick connection underneath.
Okay. And then when we talk about what browsers have currently implemented, nobody has implemented sharing any. There's one HTTP transaction, which is the web transport session, and that's it.
That's correct from all the browsers I am aware of at this time. But Martin, or I guess Martin's gone, but if someone from Mozilla or Eric from Apple wants to jump in.
I believe you're correct, David.
Okay. And then I guess the other question we were just talking about server vendors, and I guess I don't know how many server implementations of web transport there are out there, and are there lots of sort of bespoke ones, or is it like, sort of the same set of people, for example, that have quick implementations and HTTP implementations that we're talking about? I guess I don't know.
Yeah, there aren't that many, Alan. A lot of them are I'd say they're very early.
It's certainly true of ours. It's very early. I'll yield the floor back. I'm still mulling over my answer.
Thanks, Victor.
Yeah, so the support pooling means different thing from the client and from server. So from the client specifically browser, there is a very specific meaning. I'm not sure how clear it is in W3C spec and the fetch spec that in the interaction between those two. But when we do not allow pooling for web transports, that means once you create web transport, once you create a web transport object in the browser, we will create a dedicated connection for that specific JavaScript object, and nothing else will interact with it. And that has some nice properties, like you can change how you do TLS certificate validation, but that also means that the thing is basically in its own universe, away from all other web networking. Now, what would happen when we allow pooling is step one. Well, we have a generic established HTTP-free connection, which is like we use for all traffic that is from client to server when we've tried to fetch HTTP-free. And the first step would be we will attempt to negotiate WebTransport support, potentially WebTransport with pooling support. And if the server supports both of those, that means great, now we can flag this connection as the connection in which WebTransport session can potentially go once once you open a WebTransport object that allows pooling. From the server perspective, it's a little bit different, but the way you already have a way to enforce pooling on servers, the way you enforce it is you basically decline all HTTP requests, and then you only allow one web transport session per connection, and that's it. There are still some control streams that are related to H3, but those are static, and you do not need to open more of those, so this don't particularly factor in flow control.
Thanks, Eric.
Yeah, I think when we're talking about kind of the previous versions and that kind of thing, like there's a huge amount that's different since those previous versions. So like people are going to need to move at some point, or not, in which case that's frozen. There's nothing we can do about it. But I'm not sure that I would make huge choices about what we do for the future things in WebTransport based on people who are stuck on an old version, because like the diff between draft 2 and where we are now is not small. But yeah, I think in terms of pooling and stuff like that, Victor's point about the server can always decline to answer other requests or have other streams come in. So it's not like you can't prevent somebody from doing that. And in fact, if you use your flow control to set the maximum number of sessions to 1, you're in almost pretty good shape to have rejected pooling anyway. You just have to deal with rejecting other HTTP requests. So I don't think that's a huge decision factor in terms of whether or not this should be mandatory.
Victor?
We actually only have 2 backwards incompatible changes between draft 2. One of them is we renumbered a bunch of stuff, and 2 of them is we disallowed a frame. We disallowed you to put frames before WebTransport stream, magical byte. But other than that, they're mostly all of other changes we did were backwards compatible. It's kind of really nice because I think we actually shipped a lot of them, like the code way. We have code for that. Even if you don't believe that this would be a practical problem in terms of deploying things, which I believe, because I think I'm not sure about web APIs, but there's a long story of vendors and introducing APIs and then introducing a much more complex APIs that does things better, and then never being able to deprecate the old API because the complexity gap. But And that's a practical situation we might find ourselves in. But even on purely conceptual level, I do not believe there is any particular reason to do flow control on what we in browsers refer as dedicated HTTP connections for web transport, because that is literally does not do anything.
Thanks, Victor. I just wanted to jump in as individual contributor just to say, on the topic of servers disabling pooling, it's pretty straightforward to just put your server on a different host name, and that way, like, you're not going to have any GET requests, or you're not supposed to. And if you get anything there, it's very easy to just like close those streams. Though, I'm realizing as I say this that it could take some flow control credits. So anyway, maybe not as easy. Never mind. So in terms of where we go from here, I've heard kind of support for 1 and 2, and it's not absolutely clear that we have a clear winner right now. Perhaps maybe we switch gears to talk about the proposals for a bit and see if that conversation might be more likely to land on something. Bernard, can you go back to the slide that has the 4 of them? Let's see which.
I think it's actually 41.
Oh, thanks. I mean, that's what it is in the latest version, but we forgot to update the
that's what
PDF
happened.
on Meet Echo. Yeah, so it's probably one of the early ones. Let's see. Yeah, slide 16. There we go. Thank you. All right, so I haven't heard anyone speak in favor of doing nothing, but you still can. What are folks' thoughts here? Do they have strong preference on one of these proposals? Victor, go ahead.
As I said, my position depends on whether it's mandatory or not. If it's mandatory, I'm in favor of B, maybe even A. If it's not, B, both B and D are fine.
Okay. Thanks, Victor. Anyone else have opinions? Bernard.
Yeah, just speaking for myself, I basically agree with Victor that making it non-mandatory, I think, would make B or D sensible. But if it's mandatory, then probably I'd want A, maybe.
Okay, thanks. Victor?
I wanted to give some probably meta commentary as to explain why I feel so strongly about the complexity in the protocol. So,
Please.
Which I feel might be useful to some people. So back in the day, the only way you could use unreliable transport on web was RTC data channel. RTC data channel, if you wanted to use it in client or server setting, required that your server ships an ICE server and DTLS implementation and the user space SCTP on top of that. It was in this combination of a lot of stacks and parts that nominally do not do, like parts like ICE nominally did not do anything, but it was still there, and you still had to read the 100-page RFC to find the 5 pages that tells you how to not implement ICE. Things like that, or the major reasons people found RTC data channel unsatisfactory, and it was basically never widely adopted by web developers as much as, say, WebSockets, and people even did things like conferencing over WebSockets just because data channels were that bad. Web transport motivation for existence largely arose from the desire to rectify the situation and provide solutions that is simple and for which we can maybe not quite at WebSocket level, but have a similar level of diversity in terms of server-side implementations, and that people could easily use them. Because of that, I feel like not adding layers of complexity to the protocols where they're not necessary, I feel, is an important it's one of the basic reasons WebTransport exists. And if we add too many of those, we're basically to the situation we found ourselves with RTC data channel.
Thanks, Victor. Bernard, are you again in queue, or was that a stray hand? Stray hand. Okay, Eric.
So on one hand, yes, it's good to reduce complexity, and I don't think any of us are trying to push to add excessive amounts of complexity. I think there's one of the reasons that people tend to use WebSockets is because it's there, and there isn't a better alternative that better meets their needs. And part of the reason that it's there is exactly as you say, we have a diversity of servers that can use it. And a big part of the reason it's there is because there isn't really a great alternative in the web platform of today that doesn't dive into some of the things that were built with a very specific purpose in mind. And I think that's a little bit different than just it's complex. It's also complex. The main point that I'd like to make there, though, is between B, C, and D, I don't see a huge delta in complexity. And a big part of that is that complexity is not necessarily exposed to the web platform directly, right? These are things that happen under the covers that control when certain promises resolve and things like that. But it's not saying, hey, this is way more painful. And so in my mind, that suggests that most of the complexity is on the server that needs to implement these things. And that is also the place where flow control is, I guess it's necessary on both sides really, but it is also important on the server, in part because you need to be significantly careful about how many clients you're willing to handle at the same time and how many resources you're willing to give to each client. So I don't think that pulling in something that we've already implemented that looks exactly like the thing that you implemented for Quick, that looks exactly like the thing that you implemented for H2, et cetera, is actually massively complex. Now, we know that flow control in general is complex, but I think we've established here that option A of doing nothing isn't a option that meets our needs in other areas. So if we're going to have to bite the bullet and say, yes, we do in fact need to offer some kind of flow control, I think that to me does not say, oh my God, nobody's going to want to implement this because it looks the same as the other things, and I don't want to type that, or I don't want to use my implementation from there over here, or anything like that.
Thanks, Eric. Before you go, I think I'm reading between the line on which of these options you like, but could you just say it explicitly?
Sure. I mean, somewhat unsurprisingly, I think where we land is that D is the best option. Architecturally, I kind of like C, but I think for timeliness reasons and the let's not stall out making progress on making the perfect general thing, we would probably need to yield on doing C and do D for now, and we can always come back and do C again. I struggle a lot with B because it feels like it adds the illusion of doing the right thing and doesn't necessarily actually have the effect that is required. And so it feels like a solution that gets you to a place where you feel good about what you're doing, but potentially still have all the same problems you did before.
Thanks, Eric. The sense I'm starting to get is that if the question from the other slide were to only require this for pooling, D is starting to look like a winner to me. So if you disagree with that, please get in line to tell me why. Okay, Alan.
Okay, I was in line before you said that, but I'm not going to tell you that I'm not disagreeing with what you said. Like, I guess I want to say
That's okay. I'll allow not disagreeing.
Okay. I don't think we should do nothing here. And I'm not hearing a lot of people advocate for C, but I want to just sort of add my voice to say, well, like, I don't think C is the right thing. In addition to the timeliness factor, it might be the right thing someday, but I've always had this weird feeling about WebTransport is trying to offer the quick API to applications. And if in order to do that correctly, we have to add more features to the quick API, then we create this sort of like weird circular recursive thing, or we have to like say like, oh, well, yeah, we created stream groups, but WebTransport can't actually use them. We created them so that we could implement WebTransport, which would just be weird. So I think I think it's just one more reason to like not really consider C right now. And I think in terms of like the complexity, and there was a discussion about like how much we want like this protocol to be a success, and we want people to use it the way that they have used WebSocket. But I don't necessarily see that the adding flow control or even if it was complex, I don't think that's going to be a barrier, because that is going to be completely hidden to basically the 12 people on this call, plus like, I don't know, 12 other people in the world that are like implementing this in browsers and in the like 10 most popular servers. And I think they could probably also, if you got to, even if you had to, and it was mandatory to implement flow control, and you weren't going to support pooling, you could just set everything to the max probably and like pretend like it doesn't exist. And I think Eric's voice is really powerful here, because I think Eric is the only person who's implemented it. And he keeps saying it's actually not that bad, guys. So I think maybe one path forward might be to say that this is how we're going to go forward, is with D, and get interoperability on it to force the, I don't know, 3 or 4 other people on this call to implement it. I'm looking at myself also, who's like in the I don't really feel like it today camp. And then kind of come back to it and be like, oh, well, it really was a lot really complicated, or really it wasn't. But I think there's a lot of like uncertainty about like, oh, it might be complicated, or I don't want to. And that's kind of in the way of us choosing what's probably the right option.
Thank you. Eric?
Just to the having implemented it part. So we've got the stuff that's prototyped, and I don't think we've finished all of our H3 stuff. So if you go try to turn that on right now, I don't think you actually see it in any builds that anybody can see. That said, one of the things that does come up as we talk about how flow control gets implemented is very much this like, how are we representing like the fact that these different streams are all part of this session, and if you close the connect stream, we'd have to go back and view them. And it turns out that like a lot of the same, like there's definitely challenges there, but as far as I can tell, a lot of those challenges are the same things that you have to do to be able to handle like other errors that occur on the WebTransport session that cause you to have to kill all of them and things like that. So there's not a huge like, it's not nothing. Like you do have to put some thought into it, but as far as I'm aware, the thought that we put into it ends up being the same thought as you kind of have to do for the rest of it anyway.
Thanks, Eric. So the sense I'm getting from the room is that everyone can live with D, and some folks really prefer it. So maybe that's kind of where we go. Of course, we'd confirm this on the list. But Bernard, can you go back to slide 40, please? All right, so assuming for now that we go with option D, let's revisit this conversation here, because I heard Victor and Bernard say that the requirement for them to be happy with D was to do 2, so only make it mandatory for pooling. And so I'm asking, is 2 plus D something that people can live with? Victor?
I can live with it. So I wanted to comment something about server implementations. I feel like a lot of people seem to saying that it's okay to make like HTTP3 more complex, like WebTransport more complex, because there will be only 10 people implementing it. WebSockets is implemented by like hundreds and hundreds of people, and I may or may not have implemented one just when I needed one in C++ and like 300 lines when I needed a server for WebSockets. You can't exactly do that for H3, even though H3 is conceptually simple, but we still have to deal with QPAC, which was, I consider, a major design oversight of H3, and I complained about it on Issue Tracker, but that was too late in the process. But to answer your first question, I'm okay with option 2 plus option D. That's perfectly fine.
Thanks, Victor. Eric?
Yeah, I just wanted to amend prior comments there. I think I had a slight preference for 1, but if where we end up is 2 with D, I think that would be a totally fine place to go. And I don't think we've thought of any place where that leaves somebody totally screwed. So yeah, let's go for that.
Thanks, Eric. Thanks for being flexible. Appreciate it. Bernard?
Yeah, I like 2D as well. What I would say is there's a couple of server implementations that don't do pooling, and it'd be nice to just kind of get them out there. And then once they're out there, and they have some feeling for it, that they would do pooling, and then you could say, hey, there's this extra thing you have to do. And they would, take it upon themselves to do it, but they'd at least get something out there. So I think 2D is good because it doesn't slow the momentum of WebTransport in general. And I think we will get pooling implementations, with all the bells and whistles eventually, but we don't have to make that mandatory now.
Awesome. Thank you. Victor?
Yeah, I wanted to comment something about the complexities that I feel like the complexity from my perspective does not only comes from the fact that you need to like send the frames and do accounting. Part of the complexity is that like now you add like your quick layer has its own buffer, but like if it's blocked by WebTransport layer, you now need to like add a buffering layer on WebTransport, and now you need to figure out how those interact. And yeah, there are also potentially other things. Yeah, so that's like there are some complications with stream state management that are not almost might not be apparent, but now that more I think about like what would it go into implementing those, the more I see that there are like some potential rough edges that would be nice to avoid in cases when we do not want to encounter them, which is when we don't do polling.
Thank you, Victor. Alan?
Yeah, so I am a little curious what one would look like if you weren't pooling and you really didn't want to do anything. Like, is it just sending 1 or 2 frames that's like you get 1 million and then calling it a day? Like, that's kind of what I'm thinking. I've been thinking about it in HTTP2. If you didn't want to do flow control, like that's what you would do.
Well, you're talking about the receive direction, in which case, if you don't want to impose receive limits, you just send, hey, my limits are infinite. The problem is when you're sending. If you're an application, like a server WebTransport implementation, and then your application wants to write, and the client says, no, I support flow control, and you can't write that much, you have to buffer the data at that point. So you need to implement it.
You're saying so the server has set a limit smaller than infinity, then the client has to handle the buffering. Is that what you're saying?
Like if the peer has set a limit, you need to manage your sending to respect the peer's limit.
Okay.
Yeah, you can't unilaterally just opt out, but at the same time, like if both sides are trying to opt out, then yeah, they can both just set it to a bajillion and it just doesn't apply. And if the other side isn't setting it to a bajillion, then perhaps they needed it. But I think there's no, like all of those things still apply. You can still end up in exactly that same situation if you're not pooling. It's just a different number that is doing it to you. So like there's no new place where you could have avoided back pressure in the past and can now cheerfully skip it. It's just there's another place that could have caused that same back pressure to happen, but it's still the same signal to the client, as it were, not client server, but the person using WebTransport.
So
like
okay,
you're not far off. Like you could just set it to 1 million, and technically both sides could set it to 1 million.
But if you don't know for sure that your peer is going to set it to 1 million, then you still have to handle that case. Okay.
And arguably that doesn't matter, right? Because like the peer is already potentially not going to set the lower layer flow control to 1 million, and if you're not pooling, then that flow control still affects you pretty much equally. And so like you have all the same concerns about, hey, I can't send at this particular moment, and hey, I need to make sure that I'm not offering people a way to write way more than I'm willing to buffer, and all that fun stuff. But yeah, so like I think living with two doesn't drastically make people's lives easier there, but if it makes it easier for people to do, I think that the other piece is really, like to Victor's point, if we discover that this is radically, massively painful to implement, then like, great, that's part of the point of our IETF process is to take that into account. So like, this isn't like we're here and we're done and we're never going to think about it again. This is more like we're going to take this as a direction, and then go from there. So
I jumped out of the queue to like if that's what you wanted to say, and then I had another thing I wanted to say. So was that what you were in the queue for?
Yeah, I stuck it in there at the end.
Okay, that's fine. So I get, yeah, and I think it's similar, I guess, which is like my feeling is that we really shouldn't ship this without at least a few interoperable implementations of pooling, even though the browsers are sort of in a place where they're like, we're not shipping pooling right now, and we'll think about it later. And I hear Victor saying like, this may not work at all. I'm not sure. But I really think that we're probably making a mistake if we don't have like some implementation somewhere to show that like all the stuff we designed like actually works and it's interoperable and it's implementable. Because it would be kind of a shame if we were like, oh, we think pooling works on paper, and then somebody tries to implement it later and then it actually doesn't work.
Absolutely. And speaking as chair, like we're not planning on starting working group last call until we have like implemented every feature of this protocol, because you're right, otherwise you could end up with something that just never worked. Lucas.
Hello. Just to respond to your points, David, about sticking stuff on different host names. With my Cloudflare hat on, my employer hat on, that's not something we support for like WebSockets. If you want to support WebSockets, you can, but we don't provide an ability to say only support WebSocket requests on this host, otherwise reject everything else, and only support other requests on this other host, and do stuff, partly because it's easier not to bother, partly because I don't think anyone's ever asked for that. That said, we only support HTTP 1.1 WebSockets, so some of the problems related to pooling here don't count anyway. And I think even trying to describe that to people is difficult. So yes, if you're deploying these services yourself, sure. But if you're trying to sign up to something, anything reliant on multiple host names, I find in my experience really riles people up. So yeah, I'd like to avoid that if possible.
Okay, so I mean, we need to make sure that the server has a way to disabling them. That makes a lot of sense. That said, in the CDN use case, like Cloudflare, you're probably, if you're implementing WebTransport on your front end and you're allowing this kind of thing, you're going to have to implement pooling, right? And therefore flow control.
I haven't thought enough through to that yet.
Okay. Or actually, are we saying that we need a way in the protocol, such as a setting, for the server to say, hey, don't pool on this, period. Actually, yeah, the WebTransport max session set to 1. So maybe, yeah, sorry, that's how you disable. You don't need to put on a different host name. You just set that setting. Sorry. I think
Right.
that's the answer. All right.
Yeah, that should work.
Oh, cool. All right, we've drained the queue. I like the sense I'm getting is that everyone can live with 2 plus D. So we're gonna declare, we're gonna check the consensus on the list, but sounds like that's our tentative plan moving forward. And hopefully the folks who couldn't make the meeting or the second half of the meeting today think that's a outcome they can live with. Was there anything else that we wanted to use the time today, Bernard, or should we just kind of wrap up here?
Yeah, I think the only thing would be is if there's some other action items that we need to just check and make sure we do, other than the check on the mailing list.
Yep, I'm not seeing anything.
Okay,
All right. Lucas?
Chris?
Yeah, I don't want to distract from actual working group stuff, but since it's WebTransport, and I only realized we're meeting today. Sorry about that. But kind of in related stuff, Kazuo and I published a draft about quick on streams and HB3 on streams, and I saw Victor responded to that in relation to WebTransport, and there's a lot of overlap with H2 on WebTransport, which is not something I paid that much attention to, I fully admit. So obviously we're doing the work we are here, and part of the discussions we had today related to some of that. I just wondered if there's anything we can do to keep that discussion going. If we don't want to keep the discussion going, I don't know, like Kazuo and I are going to carry on working because what we have is a solution to a set of problems that we have. And it wasn't designed specifically to address anything in WebTransport. But if there's some upside, brilliant. I just wondered if anyone wanted to comment while we're here.
Yep. Just before we open the floor, I'm going to declare this meeting of the WebTransport Working Group over. And this is now a hallway conversation about this draft, which I think is great. And feel free to use the rest of the time. I'll be writing up the consensus call while you do that. So this is not officially WebTransport anymore. It is still covered by the Notewell as an IETF hallway conversation. All right. Discuss, Victor.
So basically, my observation was that WebTransport over H2 is just saying that, well, WebTransport is a saying that gives you something that's shaped like a quick connection. And WebTransport over H2, despite having H2 in the title, as long as you have something to do like headers, you can run anything over it, including HTTP3. Technically, WebTransport doesn't give you stream IDs, but that's mostly an API consideration that we chose because we assumed that those things would be proxied and the stream IDs would not be consistent. You can totally get those stream IDs. And in fact, like right now, I've not finished WebTransport over H2 implementation, but you basically can take the same application, in our case, let's say MOQ, and you can run it over WebTransport over H3, you can run it over raw quick, and you can run it over H2. I want to say H2, but technically it's anything that lets you exchange headers and looks like a stream. So it can be H1, it can be WebSocket, it can be anything. So my worry is that we will end up with two things that basically do the same thing, do the multiplex streams over TCP with quick style flow control. And I would basically prefer to avoid that. So there was some discussion before in WebTransport over H2. In fact, there is an issue of can we extend the applicability of the protocols that we defined to non-H2, and the agreement before was we will not formally define it for anything other than H2, but we would describe how it could run over those protocols, potentially, as a non-normative text. So we could maybe spend more time discussing that, because outside of the fact that like I do not see any conceptual things other than the stream ID issue that would prevent someone from running H3 or WebTransport or whatever.
Yeah, I would second some of that, and I unfortunately needed to drop in a second, but yeah, it'd be good to talk more about it in detail and kind of see what are the needs that we're trying to address, because we made a couple of very conscious choices even before running any of this stuff over H2 as WebTransport over H2. It was a very deliberate attempt to make it so that we could run something like Quick over TCP in the cases where you needed to. And one of the very clear goals that I think we sometimes forget a little bit as we focus mostly on WebTransport over H3 is WebTransport is not even really supposed to be H3. WebTransport is, we think that there is a modern way that multiplexing protocols should work. And H3 is the current state of the art there. But if H4 can't also expose a similar thing, or if Quick v2 can't do something similar, then we're going to be sad, right? The goal isn't to just make different WebSockets. The goal is to say that this is how you should transport bytes from A to B. And we are very much planning to offer the same API for Quick as we offer for WebTransport. And the idea is that you can run, just like Victor said, you can run your same code on Quick, you can run that code on H3 via WebTransport, and you can run that code on H2 via WebTransport. And to Alan's comments, yeah, that is TAPSy, but it is not, I don't think that that concept is exclusive to TAPS. So we also, when defining the current set of frames, deliberately made it look very much like Quick for WebTransport over H2. So one of the conversations that we had when defining that was you could run that over WebSockets, right? You could run that over literally anything, as Victor said, that exchanges headers and has a bidirectional byte stream. Now, anything that you can explode out to get better, independence of different streams and less head-of-line blocking and stuff is great, but fundamentally, there's absolutely nothing stopping you from running that same thing anywhere that you wanted something that looked like Quick over a random TLS connection or a WebSocket or literally anything else. Yep, that's random Quick stream, literally anything. So yeah, that was very much a conscious design choice. We didn't bother to go write up all the stuff that you would need. I know Martin Richter and some other folks have asked about it, written up some documents on how you would do that over WebSockets. And that could be a nice way to kind of offer a polyfill style thing there. But this very much was an attempt to say, hey, we've got Quick, we'd like to be able to do Quick everywhere. Can we offer that in a way that looks the same as Quick and provides 99% of the same benefits, modulo what kind of unreliability you can get underneath?
So to clarify some things that I'm not sure, might be very unclear if you're not following WebTrans group. Originally, we started original design for WebTransport over H2 was we kind of did the WebTransport over H3 thing where we took H2 and reused H2 streams as WebTransport streams. And then we concluded that unlike WebTransport over H2, unlike H3, we don't really get anything from reusing H2 streams since they're all linearly sent over TCP anyways. And we had a problem where WebTransport over H3 was using the Quick style flow control, and WebTransport over H2 would be stuck with H2 style flow control. So at some point, the draft was dramatically changed to basically be H3 to run Quick over H2, but instead of Quick, it's capsules that functionally work the same as Quick frames.
Cool. I don't have much to add. Just this usual hallway chat. Thanks. It's given me some things to consider. We're planning to present some of this work at Brisbane, potentially between the HB working group and the Quick working group. I don't think we should waste any time on the web transport session. Hence, we haven't really spoken to the chairs about that. So if anyone wants to come and chat some more, yeah, do so. Be great.
All right. Thanks, everyone. Then I think we can call it. See a few of you in Brisbane, I hope, and otherwise see you on the mailing list. I'll send out the consensus call later today. All right. Bye, everyone.